它摁一下就行，这里摁一下让它绿了就可以。要把它放开来吗？哦。哦，这个。看一下可以吗？那我关了。
All right. Welcome to the last day of our Halves presentations. I think we have 5 teams today. Anyway, I will be keeping track of time for you all. You have 15 minutes. I've got the little signs, so watch for those. We'll have 5 minutes for questions. And I believe we're streaming. So welcome to the people viewing us on the stream. And for those of you who are watching, Halves is a chance for the teams to present where they are in their semester, and in particular, give us a sense of where they're going and what their vision for the rest of the semester is going to look like. And so with that, I think we're about ready to go. You guys all set? All right, let's do it.
All right. Hello, everyone. We're Theater Archive. I'm Shan. I'm the producer. This is Bokang, our programmer, Damien, our designer, Ray, our 3D and graphic designer, and Jingren, who's doing UI UX for us. So Rolf and Mo are both our instructors, and Rolf is also one of our clients, as well as Mia from La Mama. And Billy and Jae-hee are both our external advisors. So just a brief introduction on our client, La Mama. It is founded in 1961 by Ellen Stewart. It is actually an experimental theater club that's for artists from all cultures, identities, ages, and races. So you might not be familiar with La Mama from the first slide, but you might be familiar with it now. So La Mama actually hosted Blue Man Group, Sam Shepard, and Willem Dafoe in the past century, and they grew together and shaped La Mama to what it is today. So looking at this, we will be working with the La Mama archive. And once you go into the archive space, you will see beautiful poster walls, even props from their shows, and masks, and even a room full of puppets. So we will go into details with each of the pictures later, but let me explain our client needs. So we had a few meetings with them to identify their 2 needs. One is that they would like to expand their digital access to the archive, and the second is they would like us to provide a prototype to launch in the archival space and to fundraise for a bigger project later. So what we decided to do is an AR archival experience. So let me identify our target audience. So one of the group is, of course, students, including high school students and college students. And we also welcome performers who are touring in La Mama to visit their archive. And of course, archivists and researchers. And our goal is to reach out to more funders with our project to fundraise later. Now I'll pass down the mic to Bokang to talk about our design goal.
Thank you, Shan. So first, I will talk about our use case. So you go on a private in-person tour at La Mama archive, and after the tour, you will have some free time to explore the space by yourself and explore the AR experience. So our design goal for the audience is first, you should access all the AR experience easily, and you should understand all the interactions intuitively. And also, through the experience, you should learn the background story of those items. And finally, all the interactions and experience should be cohesive. And here is our method. First, we will choose some signature items in the archive, and then we will do a research on their background stories, background informations. And finally, we will customize interactive AR experience based on our research. And we also did some research on a similar project, including the existing AR archive experience, also the past ETC project. So what we learned is, first, the AR experience should really integrate with the reality instead of disjointed with the reality. So face filter is a really good example for this. And also a good AR experience should use the interactions and virtualizations to show the in-depth background story of those items. As for the tech stack, our client needs is it should be user-friendly, and all the code should be easy to maintain and scalable. And finally, they want to deliver the experience easily. So after considering their needs, we choose Web AR as our tech stack, and we choose ASWAL as our platform. So the advantages of Web AR is the user do not need to download any apps. They just need to scan a QR code and open the web browser. Then they can start the experience. As for the ASWAL, it provides the cloud code editor, also built-in hosting, which means the client do not need to host any server. They can maintain the code and publish the experience very easily. So as mentioned before, we will customize AR experience for each items we pick, but we do have a general similar opening for each experience to make them cohesive. So first, the user needs to scan a QR code which close to the items, and then we will show a playbill to tell you which these items come from. And then you can read some brief introduction, and then you can close the playbill and start a tutorial. And finally, you can start AR experience and learn more information about this item. And we already picked 5 different items in the archive, which for the first row, which includes a poster, a bench, and a collage, we already have a demo for that. And for the second row, which includes a mask and a puppet, we already designed the experience but not implemented yet. And here we also want to define 2 different interactions we create. So the first type is interactive story, which means we will use the interactions, the virtualizations, the audios to tell a story related to this item. And the second type of interaction is AR video, which means we will use the video, the photo, to show the background story of this item. Now our teammate Damien will introduce our first interactive story in detail.
Thanks, Bokan. So I will use Llama Revision as our first example of our whole interactive story. This is a Japanese show talk about the relationship between a mother and a son, and there are 2 main characters in the drama. Like the first one is Mary, who is a prostitute, is a transgender prostitute, and the son is her first son. And why we choose this story? First thing is implication didn't show on the poster. You can see there are so many metaphors, but you didn't know more details about that. And the second thing is about cultural diversity. This story talk about a lot of interesting elements in it. Talk about the sexuality, talk about traditional Asian family relationship. And besides that, this poster is really eye-catching. You can very easily to find it in the world. And it's kind of a representative drama about La Mama because it's a experimental theater, and all the drama is really avant-garde. And how we implement this story, we will use live poster with visual and audios. This is our demo.
Mary, look, there are many butterflies in the room.
I told you, don't call me Mary, call me Mom.
All right, Mom.
Good boy. Now catch them all.
Mom, I got an Agrias.
Well done.
Another one. They are very precious.
Yes, their color is unique.
Really?
Of course, I dyed their wings.
I'm going to treasure them. But why these butterflies look unhappy, just like me, trapped in a cage?
This is all about love. Mom's duty is to protect you. Once these beautiful butterflies fly to the outside, they will be dead soon.
Once you finish
Just
whole
like
interaction, you will see an info button that you can click it and to see more information about our characters. So for the demo, the butterfly is kind of represent the freedom, and the little boy catching the butterfly means it's kind of a restriction of the freedom, and the boy cannot go outside because Mary did not allow him to do that. And we have over 15 playtesters on Wednesday, and they give us a lot of invaluable feedback about that. There are some good things that we heard from the audience. They say that we have really interesting and immersive interaction. Besides that, the integration with the reality also is really good things for them. And our art style is really beautiful. But beside those good things, we still have something need to improve. First thing is we lack of enough and clear introduction for the audience. They need to tap the butterfly to catch it. And we lack of visual feedback once they caught the butterfly. And also the background music and the voice kind of problem for them. They cannot fully understand the whole story. So for the more progress, I will hand over to Ray to talk about it.
Thank you, Damien. So one of the demo we're working on is the Carmela bench interaction story. Carmela was the adaptation of a 19th century Gothic vampire novel, which was first produced by La Mama in 1970. The bench on the left was the only prop and also the stage in the show, which is one of the significant exhibits now preserved in La Mama Theater. Those white masks were once real actors' faces painted in brown color and hidden in the bench. And during the show, those faces would sing and make expressions. To show visitors this unique stage design, we plan to use face filter on the white masks to replace it with our modeled human face, painted in the bench brown color, and make the virtual face performing with the audio from the original Carmela show. And here's the demo. So those eyes would suddenly open and create this jump scare we want, since it's a horror show about vampire. So far, the animation of this hat is just a placeholder. And just like the other ones, visitors could click for more information after. And another demo we're working on is the poster collage, which allows the visitors to scan some of the posters they're interested in and get to see more photos or videos or informations related to these posters. And here's a demo.
The World of Feelings is the theater of Alan Stewart.
So next, Jingyuan will introduce our next steps for the coming weeks.
Thank you, Ray. So this is our timeline after half. So our team plans our second trip to La Mama in week 11. So before that trip, we'll keep polishing the 2 demos you just saw. And also we'll finish our puppet MVP before week 9. And we will finish our mask MVP before our trip to La Mama. And after we're coming back, we'll use the rest of time polishing and iterate on our overall experience. So I will introduce our mask experience first. Why we are choosing this mask? Because this mask cannot be touched or moved in the archive. So we plan to build the 3D models of this mask for our visitors to try them on. And they can also scan and see the details of these models.
And we are planning to create multiple face filters with related makeup and also related costumes so that our visitors can have option to choose from. And they will be more interested to take selfies and then to share it on the social media. And for our puppet experience, we chose this puppet from a show called Local 7. You can see in this video, there's actually a man in black who controls the movement of the puppet. But also the same problem. In the archive, people cannot touch or see the movement of the puppet. The puppet is merely on display. So we designed to use the body tracking technology for our visitors to wear the puppet and perform with the puppet. And for our final deliverables, first we'll have 4 main interactive stories, and then we'll create multiple AR videos of all the posters and the photos in the archive. For all these experiences, we'll generate the QR code for our clients and hand over the source code. Finally, we'll have a good video documentation to show our work. So this is our summary. Thank you for coming to our Halves. We are now open for questions.
AR often builds from setting, where you're using the background is like the stage for what you have. But some of this, the masks and the puppets, look like it could run outside of the setting, a take-home experience. Have you thought about what has to run in the theater and what might run after the experience?
Sorry, let me repeat this question. What might run in the theater? Can you clarify?
Yeah, are all 4 only going to run in the theater, or is part of the client's thinking that they want more brand awareness, they want more marketing, they want some take-home things, and like the last 2 seem that they could easily run at home afterwards?
Yes, so right now, our goal for the semester is to only allow experience to run in the theater. But of course, if you get our QR code, you can do whatever you want at home or outside the theater. Yeah.
Hey, a bunch of your different prototypes involve sound, and I'm sort of wondering how that's going to work in a space if multiple people are trying to look at the same thing at the same time, right? Because then they'll have video playing at different times on their phones, and it might make it noisy. Is there any way to deal with that?
Yeah, we identified this problem in our playtest. So we'll implement the subtitle, and we also want to create an experience that if you can't listen to any sound, you can also know what is going on. So we'll keep this in mind later.
So to go on what Mike said, context is everything. And by taking all of these elements out of their context, you lose meaning. So is there a way to get around, taking the items out of context and putting them back into the context so that they actually have meaning, rather than just become a toy? I don't know.
So by context, do you mean the original show?
I mean, La Mama is very specific experimental theater, and when you remove the items out of that context, that's what I mean. They just become stuff. They're just items. They aren't. They lose their meaning.
I think so. We have 2 approaches to solve that problem. So all of the videos that we just shown are playtesting in our room, which has a huge gap between our green room and the actual La Mama archival space. So what we'll do is next month we will visit La Mama and then install those QR codes so that the visitors can actually be in that space and then have the whole 2-hour archival tour, get an understanding of La Mama, and then go on a free tour with our AR experiences. And the other approach is that we're trying to make the story back to the experience that we're making. For example, the Mary poster that you saw, but it's not as obvious for the bench and the face masks right now because we have not built a comprehensive demo for that yet.
So good morning, everyone. We're A Square Studio, and here's our Halves presentation. So we are a team of 4 second-year ATC students, and our instructors are Scott and Brenda. Our client is Alice, and over the semester, we're consistently working with the former ETC faculty and now the director of Alice, Melanie Lim, and the lead developer of Alice, Daniel Halves. And before we introduce our project, we want to first introduce what Alice is. It is a CMU technology, a block-based programming environment for students to build animation and interactive stories. And it has 2 big components. The first one is 3D scene building. So if you go into the engine, you have a selection of 3D models that you can drag and drop into a 3D world to build a 3D scene. And the second half is, after you finish, you can select any game object and attach behavior to it through its block coding feature. So Alice is currently a solo educational experience. So it has a selection of official tutorial and lessons, including sample projects and facilitation guide. And they pass this to real teachers in the school who turn them into lectures, and they do concept demonstration and allow students to do independent projects. And that's how Alice is currently being taught. But with everything being remote these days, they're also wondering the question, what would be like in a remote collaborative learning situation? In other words, how can students learn Alice in a remote classroom? And that's why we created this project. So our task is to help Alice explore this direction by creating a proof of concept experience that enables middle school students to learn 3D scene building and block programming through real-time remote collaboration. And because we're focusing on the proof of concept experience, we're not actually required to use Alice or add features to Alice directly. So how do we tackle this problem? The first step we took is to actually research our target audience. So we found out that middle school students are in a stage where they're building a lot of self-consciousness, they're exploring interest for their future career and education, and only 23% of them, according to a research paper, have previous programming experience. And a surprisingly high number, 17% of them are underprivileged, meaning that they don't have proper access to educational resource. So we solidify our target audience to be age of 12, and we want to specifically target those who have minimal programming experience, either because they haven't had any programming experience before, or they don't have access to educational resource. And our short-term goal is to give them a basic understanding of 3D scene building and block programming, but in the long term really spark their interest in STEAM learning as their future career and education. So the next step we took is we did a lot of research on what's out there on the market. We categorize all our findings into 2 big categories. On one side, we have 3D scene building experiences. Those are really focused on freedom and creativity, but at the same time, they are very unstructured, meaning that their educational value does not get delivered consistently, and also they often leads to negative behavior in collaboration process. For example, griefing is a big problem. And on the other side, we have programming games. And those are the games typically involving using a programmable character to solve a predefined puzzle. So those are really structured, that carries educational value consistently, but if you cannot solve the problem, this can easily lead to frustration. And also they're not collaborative at all. So we think our experience kind of like lies in the middle. We want to first combine both experience into one, and also want to provide some structure that delivers educational value. And thirdly, we want to add in positive collaboration as our secret ingredient. So speaking of positive collaboration, one of the things we learned early in semester was improvisational acting, which turns out to be a huge inspiration for our experience. So we have one improv session with our instructor, Brenda, online, where we explore a number of different activities remotely. And we learned that improv is all about making an offer. You want to make you want to make your partner look good. You want to be fun to play with, and you want to serve a narrative. And most importantly, you want to say yes and. Always say yes and to your partner's work. And which is exactly the perfect definition of positive collaboration. So we turned this into a huge inspiration for our experience moving forward. And at Quarters, we have a solid understanding of our problem space. We want to have an engaging activity. We want to foster positive collaboration. And we want to have a clear learning objective. But the biggest piece of feedback we got from Quarters was that the relationship between collaboration and the learning objective was unclear. Because there's a big difference between collaborate to learn and learn to collaborate as a skill. So after Quarters, we had a lot of discussion with our client and internal discussion, and we solidified our learning objective to be strictly what Alice is all about, which is 3D sim building and block programming. And we want to have positive collaboration just as a way to help us or help the students get there. So at this point, we have 3 drastically different directions that we want to explore in the semester. First, we maybe kids can create an animation collaboratively. And secondly, maybe they can control a programmable character to solve a puzzle together. And they can possibly also build a playground together and use a virtual character to tour around. So we turned those 3 ideas to our client, and the biggest piece of feedback we got was a really important point that Alice is all about using character to tell stories. And to incorporate that, it became crystal clear that what we want is the first direction, because an animation is just the perfect way for us to use, for kids to use characters to tell stories. So now we have a concrete goal that we want to create an experience where 2 players collaborate to create an animated scene with 3D assets and coding blocks. So the experience outcome should be a fully playable animation video, and a bonus point is if they can tell a story through that video. And the learning outcome is selected 4 official chapters or official lessons from the official Alice lesson list that is currently taught by a teacher facilitating a real lecture. And our hope is that by playing our experience, the kids will get the equivalent of the same knowledge from those 4 lessons. And how do we do that? I'm going to pass on to Zhiqi to talk about the experience breakdown.
Thank you, Jingyu. So in our experience, there are 3 parts overall. The first part is prompt picking. Students who can choose 2 main characters, and they can decide what is happening and where it's happening. The second part is 3D sim building. Students now can create the unique skybox and ground plan. They can also pick the amazing 3D models from the library. The third part is behavior definition. They can use block programming to create the animation and dialogue and even sound effects. So here we can see this is our lobby UI design. We can see one of the students need to create a room, another one need to join the room. And then when they are ready, they just hit the start button to start the experience. So we can see 2 students can pick the main characters at the same time. And then 2 students will be assigned different roles. One is responsible for choosing what is happening. Another one is responsible for choosing where it's happening. And then they will get a full prompt, like a summary. So yeah, we also follow yes and rule from our improv class. It allows collaboration and affirmation. In this case, we can see a panda and a cat on the moon. And a panda and a cat have a party on the moon. And then before the 3D sim building, one student is responsible for creating the skybox. Another one is responsible for choosing the ground plan. So here is the 3D sim building. They can not only pick the 3D models from the library, but also they can rotate, change the position, and change the size of the models. And after 3D sim building, they will use block programming to create the story, like the animation, dialogue, and sound effects. So here is the demo video. They are creating the environment. And choose the models from the library. You can also see, rotate the models. Yeah, change the camera view position. Yeah, I'm gonna pass to Rick.
Yep, thank you. And as for the technical details, we are prioritizing accessibility. So our targeted platform is web-based, and it will be a plus if we can accommodate Chromebook. And we also need to provide multiplayer networking support, and we need to provide collaborative sim building and block programming. So we decided to use Unity as our development platform because we found out there are a lot of packages for sim building, networking, and block programming in Unity available. And we also considered to use Arena, but we just found out a lot of critical features are still under development, so we decided to use Unity. And as for the multiplayer networking infrastructure, we use Photon as the networking framework. We can deploy a server that can host multiple players at the same time. One player can host a room, and another player can join the room so they can play together. And we also want to use the Alice access library, so we go through the Alice to Unity access workflow. We export the Alice scene into Maya and convert the models, animations into FBX files and export them into Unity. And as for the block programming, we are planning to use Google's Blockly as our block programming framework. And we are also reaching out to the development team of Blockly to get technical support. And I'm gonna pass it to Shirley.
Thank you. Early in the semester, we had our first playtest with 5 groups of ETC students that we assigned pre-selected prompts and roles to them, that one of them will be working with the character and the other one will be working with the environment on 2 separate canvases. They will not see each other's works until the end when they merge the character and background together. Before the playtest, we expect that they don't need verbal communication, and our prompts are inspiring to them, and they also enjoy working independently, and then merge the work at the end. And after the playtest, we found that they don't need verbal communication, but some of them don't like our pre-selected prompts, and also many of them would love to see each other's works in real time. Therefore, for our next playtest, the biggest change we make is to turn the pre-selected prompt into a collaborative exercise for the players, and also to enable real-time synchronization in our next build. And last week, luckily, we had 5 groups of middle school students as our playtesters that we use prototypes and let them pick the prompts together collaboratively. And after picking the prompts, they will start working on the same scene together in real time. And before the playtest, we assumed that our prompts creation process was fun, and we have enough tools for them to build a 3D scene. And most importantly, they are excited and willing to know what comes next. And after the playtest, the good news is we found the prompt picking process is interesting, and all of them enjoyed the experience very much and would love to know more about 3D animation. However, there could be more basic features to be added in to help them build a scene. With 2 playtests, we have gained a valuable experience of where and how we can improve for our next build.
after Halves, we're going to implement block coding functionalities and also to further foster positive collaboration to help our students to tell a story in our experience. And yep, here's our summary. Thank you.
And we're open for questions.
Yeah, sometimes when we do play tests, we get a little bit of a playtest bias in terms of people, maybe your demographic being on their best behavior because they're excited to be part of a playtest, they're in a unique space. Do you have any plans to playtest in an actual scenario where the users would be utilizing this collaborative experience?
Yes, so the question is, are we looking for more environments and actual facilities to playtest with more middle school kids? And I think John Baelish helped us a lot to establish connection with multiple educational facilities down in Pittsburgh. So we're scheduling more playtests moving forward after Halves.
And it won't be necessarily used in a classroom. Like, would these children be at home? Just to clarify that.
So our target experience is that we can accommodate user collaborating remotely. But for now, for all our playtests, we are having kids sitting face-to-face.
Okay, so what I'm asking is, what is your real target? Is it a teacher facilitating this in a classroom? And if so, I would want you to playtest in that scenario. But if your actual target is for kids to eventually use this at home, do you plan on playtesting in that scenario?
Yes, we're also having planned to have playtests remotely as well.
How does working in real time influence the story presentation and how they're receiving the story? And if it does offer any challenges, how are you dealing with that?
So the question is, does working in real time affects the story at all?
Yeah, so if they're working in real time, does that change the energy of the story? Does that change does one person take over the story? Have you noticed any challenges with that? If not, beautiful, but if you have, how are you resolving those challenges?
Yes, I think we did notice a lot interesting things when we're having playtests in real time where kids can see each other's creation. And that somehow corresponds to what we learned from improv, because when kids are working on a scene together and they're putting in models and not communicating verbally, putting in an object is like making an offer. And the other kids can respond to it by putting in other objects. So they're collaboratively building the scene together. And based on our previous playtests, we haven't noticed any negative behavior through that process. So they're having fun accepting each other's offer and add on top of it.
I'm curious about the coding part that you're going to be getting to. What do you perceive as some of the challenges? What are you worried about when you get to that? And I'm also wondering, do you have a sense of how you will make that more collaborative than it just sort of like a student can just start programming?
Yeah, so the question is about the plan for us implementing block coding. And I think for now, our hope is we can use Blockly as our the third-party library, and we already found an open source package that we can use that implements Blockly into Unity that we can build on top of it to add in our custom features like adding animations and stuff. And in terms of collaborating with block coding, our current hope is that students will get their can only add behaviors to their own characters and own models, but we do allow the feature of like passing on objects to each other. So if I don't want to add animation to my object, I can request to pass this object to my partner, who can add in code for me, and that's our current plan.
So could you discuss a little bit why you chose Unity instead of Alice, and why you moved into building out a block coding world in Unity for collaboration instead of Alice, perhaps in more of an asynchronous collaboration mode?
Yes, so the question is why Unity instead of Alice? So early in the semester, we had a lot of discussion on the potential platforms we can use. And the biggest challenge we found using Alice is that the code base is primarily in Java, which is not our not the tech stack that we're familiar with. And also, it became super difficult for us to add more features on top of it, especially multiplayer, which is something that even the lead developer of Alice didn't recommend us to do. So we think that Unity provides us with some existing package that we can easily set up a multiplayer world, and we can just take the simplistic, the most simple but essential features from Alice and implemented it in Unity to support a similar experience of 3D sim building and block programming. Thank you very much.
Hi everyone, we are Team Pico Pico P, and we are a web-based game about cybersecurity. And I'm Tenga, and I'm the 2D artist and the designer.
I'm Shitai, I'm the programmer and the co-producer of the team.
I'm Jeffrey, I'm a game designer and a co-producer.
I'm Yiming, I'm the programmer and designer.
So our client, our client is Pico CDF from CMU Lab, and they are a free computer security education program. And our target demographic is middle school and high school students who want to learn more about cybersecurity. And they're going to learn about all the knowledge within 10 to 20 minutes if they want. And this year's scenario is going to be kind of different. Traditionally, Pico CDF always hold a 2-week contest, which give users a 2-week access to all the games they have. Well, this year, we're going to have a 1-year-long platform to host our game. And we want to encourage our audience to learn and solve the challenges on Pico CDF. Well, the topic for this year is reverse engineer and binary exploitation. So let me briefly explain what binary exploitation is. It is an approach to attack or get control of the program by typing characters more than expected, overflow the buffer, and overwrite the command in the other memory cells. Well, the concept this year is a little bit hard to approach, but we're gonna make this intimidating concept more approachable. So in order to do that, we have done some research on the related project that ETC student built years ago. And we really like the idea like escaping game with puzzles and mini games about programming and also the art style. And here are some of the games that inspired us a lot too. Like we really like the game mechanism of moving cards around and changing the attributes to the elements in Baba Issue. And we really like the idea of building a meta game like Pony Island.
So back in the brainstorming phase, we already came up with a lot of ideas based on the computer science and cybersecurity concepts. And we also drew a lot of drafts to depict those key movements and interactions in those ideas that we vision. So for example, we thought about controlling characters with scripts or transforming oneself between different data types, hacking monsters with cards to affect their behaviors, or hack and modify the statements within some objects, or even operating cute characters that represent a binary system. So we presented those ideas in Quarter Workaround, and the feedback we got mainly focused on how we could narrow down our ideas and how we could rapidly test and build. Also, we had to balance among art, story, mechanics. As for validation, of course, we want to focus on our target audience, which is middle school, high school students. We want to make sure they are engaged and that we are really teaching them the things that we want to teach. So with those feedback from code workaround and also from our client, we narrowed down our ideas to one specific gameplay proposal. We made this decision mainly based on our client's need of a high-level first, top-down approach to introduce the topics. And we also have to assume that our target audience do not have any programming background. So the game we vision is like this. It's a world where almost every object are defined by statements, and we can hack those objects and modify those statements to affect how objects behave. In that way, we can change how the world works and finally solve puzzles. Specifically, some symbols, some statements are hidden by default. So we have to observe the input and output to figure out those symbols. This is where we reflect the concept of reverse engineering. Here are some other settings of our game. So for the viewport, it's going to be a top-down 2D view. And we're applying pixel art style. Also, for the story, it's going to be a character catching the other one who is trying to escape from a cyber world.
Hi, here is our current lead demo.
Our game is a puzzle game in the cyber world. Player is a computer AI who can hack other objects and change the rule. Each interactable object has a rule panel, and the player can take cards from the panel to the bag. Player uses his bag to bring the rule cards he needs from one object to another. When the player changes the rule, the world also changes. He needs to observe the change in the world and guess the meaning of the symbol in the rule panel, which is an imitation of reverse engineering.
Yeah, to reach this point, we went through 3 steps. First is we had a paper prototype. We test our gameplay. After making some important decisions like how the arrow effect and how the player interact with the rule panel, we got our first digital demo. We play test this demo and we get many feedbacks. And then after adding a tutorial levels and to change our basic UI and the user interact action to the rule panel, we have our demo too. In total, we had 20 players play test our game. There are 11 college students, 3 middle school students, and 6 high school students. We got many important feedbacks. The things we learned is that because our gameplay is a little bit complex, we need more tutorial, and our UI need to iterate more in the future. And third is our art effects that to show different states of the objects need to improve. We also get some feedback that show the things we did well. The first is the player can understand our basic mechanism. Most of them solve all the puzzle, and they want to try more difficult level in the future. And here is our art asset. We got some environment asset and some UI asset. Yeah.
Okay, thank you, Yiming. And here are our future plans. So first, our level design, since our client is asking for an experience about 10 to 20 minutes, and according to our playtest, we have like the player will finish the one level with about 5 minutes. So we are trying to bring out 3 more levels on the topic of reverse engineering and 2 more levels or 2 puzzle mechanisms on the topic of binary interpretation. And we may combine some of the puzzle mechanism in one level so that the whole player experience can be like in the time length of 10 to 20 minutes. And on sound design, we don't have a sound designer, but our artist, Tiange, she has some prior experience with sound design, so she's willing to look in the internet, grab some free stuff for us, and maybe do some editing so that we can have some cool audio effects and background music in our game. And also for the art asset, our art assets are divided into two categories. The first one is what we use to draw the background. They are called tiles, and they are pretty reusable, so we plan to make 5 more of them. And also we're gonna make 30 more of the objects so that we can use them as the art asset of our new game mechanism and new levels. And also we have 2 stretch goals. The first one is we kind of want to make more levels because according to our playtest, some of the playtesters really want some higher, more challenging, more difficult levels to play. And also we are planning to make an open sourced Unity level editor so that if the kids are really curious about what's happening behind the surface, they can totally just get the project and play by themselves. And maybe they can even make levels by themselves too. And here's our playtesting plan. So we're gonna continue weekly playing test at Hunk Library. So we usually have 3 to 4 playtesters each week, and they come from a wide range of backgrounds. So some of them have a little bit of computer science knowledge, and some of them don't. So they're pretty close to our target demographics. And also we plan to visit high school and middle school frequently. We are planning to maybe visit them 2 or 3 more times, ideally, after the major iterations of our game. And also, during ETC playtesting day, we are planning to coordinate with Mike, with John Balish, and with the middle school and high schools to see if we can invite some of the students here to play test our game and maybe some of other ETC projects. And here's our summary of the project. So Pickle Pickle P is a game aiming for raising the interest of high school students and middle school students' interest in the topic of cybersecurity. And this year's goal is to make the competition's topics approachable to the participants because it is really harder than previous years. So that is our main goal. And we have established our core game mechanism, and we have been playtesting and iterating regularly. Okay, and thank you. That's our presentation. We are open to questions.
Hi. In addition to testing whether people can solve the puzzles, are you collecting any data on whether it's helping them understand the topics better? Do you know what I mean? So that can they answer questions about the basic understanding of these topics after they finish the game?
Yeah. So we did ask them some question about whether they are interested in trying more about the concepts or the gameplay. And most of them were positive. But it's hard to tell because actually they are middle school students. If we mention the term, right? If we say this is reverse engineering, this is binary exploitation, they still don't have the ideas. And yeah, we did ask them if they want to, are they interested in those ideas? Would they want to try more? And most of them were, yeah, positive. Yeah.
And also I kind of want to add something to that. So at first we are really struggling to even get the playtest to understand how our game mechanism works. And after some iterations, and some of the players can actually get the concept, like how the game actually works. And I think that is partly of the goal of our client, is that to make them get a sense of what the topic's like. And so that if they actually went into a game, they're gonna be like, the curve is gonna be a little bit smoother. So basically, if they can finish our game, the transformational goal is met.
I like the general direction you're going in. I can get a sense of how you can get at reverse engineering through this. I'm kind of curious how you're going to get at the idea of binary exploitation, like buffer overflows, with the mechanism you're describing.
So right now, that's what we're working on. We already have a draft of a puzzle which is specifically focused on binary exploitation. And the idea is that, as you saw on the demo, there are some slots, right? So we're trying to that the players put more cards into the slots, like more than expected. Because, like, for example, maybe there's only two slots, but we're trying to put a mechanics where you can actually put in 3 cards and one more will like overflow into the second row and replace some other cards that were originally not expected to be changed.
So you hinted that maybe you'll let players make puzzles, and that seems like there'll be some UI there to build out. Another way would be just for you to procedurally generate puzzles, where your system just kicks out lots of puzzles. So if you want to keep playing, you can pick the level of complexity and keep playing. Projects like Neo Security Lab did that in the past. Have you thought about procedurally generating puzzles if people want to keep puzzling?
Oh, I would say from my point of view, it would be even harder than just building a level editor, as level editor was already our stretch goal. Because as we designed our puzzles, we already find it quite difficult for us to come up with like proper puzzle that really generates some interest and like plan the interest curve. It was already hard for us. So just from my point of view, I don't think it's a...
I can answer that question. So because we are puzzle game and a puzzle is hard to extract for different parts, so within it's hard to generate by program to the level.
Yeah. And also speaking about the level editor, so basically we are just trying to open source the whole Unity project. So that is our like minimal goal, so that the player can actually like look at a code and make some levels if they want. So that's not like extra effort.
Thank you.
Hello, everyone. We're Team Hi. Welcome to our Half presentation. Hello. We're a project collaborating with Department of Psychology to create a game called Bitter Buster. So first, let me just quickly introduce our teammates. This is Cherry, our artist. This is Angela, our programmer. This is Yuan, our game designer. And I'm Constanza, our producer. Our client, Mike and team is right here. They're from the CMU Department of Psychology and also Institution of Neuroscience. Their interest lies in both AI and human behavior. We also have Mike to be our instructor this semester. So the ask from our clients is that they want a game to serve as a vehicle so that they can research on human-AI collaboration.
All right, so going into more detail about that research goal. So again, we're studying the collaboration between human and AI agents, and specifically that refers to the team dynamics between the two when they work together. And this is measured through the level of trust, how they make collaborative decisions together, and so on. Another area of interest for our clients is within reinforcement learning. They're looking into foraging behavior and also perceptual expertise. So before we dove into building our project, we referenced a lot of previous research works in these topics. So the first one is a paper done by one of our clients on perceptual expertise. And in this case, they had to have the people would come in and have to classify these greebles without actually knowing what distinguished greebles from each other. So they had to classify these strange creatures into different families and learn as they went along how to build that classification. We also looked into other areas of research within human-AI collaboration to get some inspiration. Looking at previous ETC projects, there was a previous collaboration that was done back in 2013 between us and the psychology department on teaching people how to learn languages through games. And we also took a look at last semester's Telepathway project and how they involved reinforcement learning and machine learning into their project. So while working with our client, we also discussed the current human-AI collaboration studied game that is being used. So this is Space Fortress, and as you can see, it's very, very simplistic. We have two agents where one would be a shooter and one would be the bait, and they have to work together to defeat the fortress. So overall, the client feedback for this was that it had very simple decision-making and there wasn't much variety in the gameplay that could be customized. So one of the goals for our game is to provide that level of customization. Speaking of which, our deliverable itself can be broken down into these main components. So what we're delivering is a dual-player collaborative game where each of the roles are very different between the two players. So we have a selector and an explorer, and we'll be referring to them throughout the presentation. Between the two players, they will have very limited communication to match with the restrictions of working with AI. And our game itself will also have additional features, which are in-game analytics for research purposes, and also supporting an open AI API to help our clients with developing AI agents and porting them into the game. So to give a more visual representation of this, our game will be able to support all four of these combinations. So we will be able to swap a human and AI however we want. For the focus of our game design, though, we will be focusing on this human-human portion. And looking into our tech stack, what this means is that our client will be the ones to support and develop the reinforcement agents to be putting into our game, so we're not responsible for that. What we are responsible for is providing a port through an agent wrapper with our game based in Unity that will allow us to connect their agent with our game. And we'll be using Photon to support multiplayer gameplay for our human players. Along with that, again, to meet the research goals, we will be providing data logging of the game itself and also tunable parameters within the game for more customization.
So in terms of development cycle, we're breaking down the whole semester into multiple small sprints. Each sprints are continued for 1 or 2 weeks for us to quickly iterate and develop the game. So far, we have finished 5 sprints, and we iterated our digital prototype for 3 times based on the feedback from previous sprints. And we're now going to introducing our current demo to you. And before we start, I'm going to introduce the background story a little bit. So there is a bitterness spreading out in the candy kingdom. You and your partner are workers from candy factories. Your job is to find as many bitter candies as possible in a limited time so you can get them treated and prevent the disease to spread to other candies. But the thing is, you and your partner both don't know how to figure out which candy are bitter, which are not. And you don't know where are them and what the distribution of them. So this is our video demo.
We start off following our explorer as they walk through the dessert neighborhood. It looks like they found a house full of candies. After interacting with the house, all of the candy's information is sent to the selector. The selector must now decide which candies are bitter, and at this point, the selector doesn't know what makes a candy bitter. It seems that right now they're guessing based on warm and cool colors of the candy. And it seemed to be going pretty well, but it wasn't entirely correct. After sorting through all the candies of that one house, the selector noticed there's another house in the neighborhood that they can tackle. They place a pin on that house to notify the explorer. The explorer, seeing the marker, heads towards the other house, and now we enter another round of selecting. While the selector is making decisions, the explorer is able to see the distribution of candies within this house. They can use this to inform them about the distribution of candies within the neighborhood and whether it's worth it to keep foraging here. The selector noticed that there are other neighborhoods to explore and submitted a request to leave. Our explorer seems to agree with them and heads towards the entrance to accept the suggestion. Now our 2 players are in a chocolate neighborhood, and it's time to get back to exploring.
So as you can see in the demo, we're basically designing this game for 3 directions. So first, we're designing a game for human and AI to collaborate together. So the two things we need to think about is how to make these two agents to communicate in a non-verbal or non-textualized way, because we're not going to introducing an NLP model into it. And also, we need to design the tasks for both AI and human to be able to play. Another direction is that we want a symmetrical gameplay so that our researchers can research on two distinct behaviors. In this way, we are designing the two players to have different rules, tasks, different views in the game, and different information to acquire. The third direction is that we also want them to collaborate and work together. And they share some similarity on that part, which means they will both have the perceptual learning experience, they will both have the impact on each other's decision-making process, and they are also both contributing to the same overarching goal.
So the next section will be the gameplay flow. As you already know, there are two different roles in our games. And since it's a collaborative game, the two roles need to connect together through our interactions. The explorer can freely explore the environment, and the selector can place markers on the map to prompt the player towards a particular location. And also, the explorer can interact with the houses and submit the candies inside to the selector, and selector will categorize them. Both players will receive the feedback based on the selector's decision. Throughout the process, the selector will learn the visual clue for the bitter candies, and the explorer will learn the visual clues for the bitter candies in different houses. The next pages will show some GIFs of the interaction and how this interaction fulfill our goals. On this GIF, as you can see, the explorer can move around to find candies, which is foraging behavior. And the next one, the selector can place marker on map to direct the explorer, which is nudging behavior. And next one, the selector is distinguishing bitter and sweet candies, which is visual categorizing. And the last one is collaborative decision-making. The players need to build trust with each other, and they need to make the decision whether to leave the current neighborhood or not. So throughout development, we've conducted playtests both internally and externally. Based on our feedback, the most players will be able to get the fun aspect of our core mechanics, such as the surprise of exploration and satisfaction of getting things right. Some of the key improvements we can make are with the onboarding process, and many players found the visual clue really difficult to find. These issues are what we will be addressing in the future iterations.
So as we just talked about, we want to build a candy kingdom for our game. So to dive into the design, we find our references for different elements in the game, including environment and character. So we decided to build 4 different themes for a 3D complex environment for a player to do more exploration and foraging with different surprises. So based on that, we will have 2D candy season pictures in the game for players to do classification for the visual clues. So next I will show what we already did for the game environment now. So the 4 themes have different styles. So the first one is a classic town with chocolate and marshmallows. And the second one will be full of creamy pinkish dessert. And the third one will be a skate park with sour candies. And the next one will be the water park with some ice creams. So here are more details in different areas. So candy seasons will live in the houses like chocolate house and cupcakes or ice cream or candy bags. So at last, here are the overall layout for the Candy Kingdom game environment. So we will add more art assets to it to make it like more pretty, yeah.
So inside the 3D world, we also have our 2D candies. They're also our perceptual learning materials for our client to research on. So when we're designing the 2D candy's perceptual features, our client bring up an idea that they actually want the perceptual feature to be tunable in future experiments so that they can combine different perceptual features in different experiments to research on different parameters. So we came up with an idea to build a candy generator so that they can actually put different type of features together. And we also, in the playtest, we find players actually need a large number of samples to actually figure out the pattern and to figure out the strategy to build a pattern instead of just memorizing all the candies. So we need a bunch of candies. So as you can see now, we have several perceptual features in those candies, including shapes, colors, corners, facial expressions, limbs, and texture. So an example to do the classification between bitter and sweet candy is that we can combine the dot texture and rounded shape to indicate the bitter candy. And we can also combine the strip texture and pointy candies to indicate that they're sweet candies. So this is actually how we are using in the game. This specific rule is not the rule that we're using in the game, but this is an example. In terms of sound design, we also create a theme song, and we change the tone of the theme song according to different neighborhoods so that it will match the characteristic and bring our players more immersive experience. And now we have talked about what we did in the past 7 weeks. It's time to look ahead to what success looks like for us. So what we want is to both meet our clients' goal to research on human-AI collaboration, but also create a game that's attractive and enjoyable to play. So we want our player to actually be able to figure out a complex strategy. They will have a feeling of achievement, and we want them to feel engaged with our narrative, feel a sense of collaboration, and also want to replay the game. In this way, we're going to build, we're planning our future sprints, which is 3 sprints and the refine stage, to meet the goals that I just mentioned. And we also want to build an onboarding experience for our human players so that they wouldn't feel lagged behind by the AI players, that they will have a learning curve in the very beginning of the game. And besides that, we're also going to be hands-on building in-game analytics so that we can support the OpenAI API and log the decision-making process in the game. So in summary, we're Team High, and we're building a 2-player collaborative game for CMU Department of Psychology, for Tim and Mike. And we're supporting them to study the collaboration between human and AI agent pairs. So thank you for listening, and we're now open to questions.
Sorry. You've made a lot of really clever choices in this project first, and I wanted to say that. But one question I had was, it was my intuition watching this that the explorer role wouldn't feel very exploratory, and it was really neat to see that you discovered that in your playtest, so that's cool. And I guess one thing I wanted to ask is, how are you thinking about changing it? I guess I'm wondering if, does the explorer always follow the nudges from the other player? And if they don't, is that a kind of Turing test so that you know whether they're a human or an AI? You know what I mean? Yeah, and sort of how can you make the explorer role feel more exploratory, I guess? Yeah.
So I think that's I think 2 questions. Yeah. So first question is will the instruction to nudge each other's behavior be mandatory? So the answer is no, it's definitely not mandatory. That's also something our client want to research on, because they want to research on the team trust between the 2 agents. If I give you the direction, would you follow the direction, or would you still stick on your own mind? That's something our client is interested in. So the second question is how to make the exploration experience more fun. That's something we're currently working on, and that's also occupies a lot of content in our discussion. So some of the idea is that we want to make the environment interesting enough for explorers so that they will find surprises in different areas, and they will also find some narrative-related storytelling that's make them feel interesting. But we're still working on this and keep play testing on this. So that's actually a good question. Yeah.
So even before we had all of our assets in, one of the key reasons why people were interested in exploring was that we actually keep the other rooms completely hidden until you enter it. And that was like a big bonus where people were like, oh, I didn't have time to explore this neighborhood. I want to play again to check it out. So definitely having a more complex environment, maybe keeping some things hidden from the explorer initially would help them out with that.
To clarify, because I didn't really get it, what is the explorer's goal? You mentioned that their job is to find visual clues for the distribution of bitter candies. Like what? I get the selector, like we're trying to find the pattern, but what is the explorer trying to solve in this world?
Yeah, so essentially the explorer firstly is the foraging goal of being able to find the houses and knowing where to forage. The second thing is we will have visual cues on the houses themselves that indicate the percentage or the distribution of bitterness candies in that house, and that would be something they would be able to learn based on the feedback that you saw with the slider. So they would see maybe like, oh, this is let's say a blue house, and a blue house has more bitter candies. Like they should be learning that perceptual feature as well.
Okay.
And also we're having the limitation of time on this gameplay, so they wouldn't be able to go through all the houses to find candies. That's why the distribution of bitter candies is important to the players.
And unrelated question, I'm really curious, how is the need to make this work with AI affecting your design and especially I think your implementation?
Yeah, definitely. I think every single design choice we've made with the gameplay, we've had to ask ourselves, like, how do we discretize this information or how would we process it for the AI? So it's definitely been a very huge impact on our game design aspects. We'll be working through the technical aspects in the coming sprints. Yeah.
I'm really impressed and fascinated about the aesthetics of the design. But I know you guys are not the researcher of this game, but I'm still really curious about like what specific question you're trying to see for the human AI collaboration. Like what, if you guys have like a specific research question onto like what, or like any kind of predictions in terms of how they're going to be different, human AI and human. If there's any, like, could you share it with us?
As you just said, we're not direct research on this project, but that's also something we're discussing with our client. Like, I think Tim can answer that question. Do you have any thought on that?
And then that also brought some requirements on our logging side, where we're logging the time it takes for both agents to take actions, how many times a suggestion was rejected, things like that, so then they can use that to inform their research on whatever question they're going for.
Okay, thank you guys.
Testing. Hello, everybody, and welcome to Future Forgers Halves presentation for Project Ecotopia. This is the Future Forgers team. Our faculty instructors are Heather Kelly and Jonathan Walton. We'll also be consulting with Jessica Hammer, Keith Webster, and Rob Hopkins on the project. Now, to give you an overview of Project Ecotopia, it is a first-person interactive narrative that
takes place over 3 time periods, shows the development of a rooftop community garden, and builds to an optimistic and sustainable future. The key ideas we're exploring with this game are sustainable community development, renewable energy, localized production, emerging technologies, and environmental activism. Our goals with this game are to create a positive vision of a potential future. We also want to inspire climate action and optimism, and we want to tell an engaging story as well. Our demographic for this game are college-age players, age 18 to 25, that have some PC gaming experience and are also interested in the topic of climate change. We've also done a preliminary survey of people in this demo and found that many feel powerless to avoiding a catastrophic future. Since quarters, we decided to include a call to action and resources at the end of our experience, the details of which will be decided in the second half of the semester. We created smaller gameplay milestones and priorities to help guide the production of our game. And we also finished our script early and began playtesting and iterating on that script.
So I'm going to talk about some of the decisions which have guided our design. Our design is heavily reliant on the IGDA Environmental Game Design Playbook. The playbook identifies 4 key predictors of pro-environmental behaviors. That would be hope, attitude, perceived self-efficacy, and knowledge. The playbook argues that in order to target these behaviors, you can use various tactics. We are going to be focusing on 4 tactics in particular in our design. The first one is sensory affects. That refers to the use of art and audio in order to help build an emotional connection between the player and environmental issues through use of the player's wider senses. In addition to that, we're also going to be tapping into systems knowledge. That refers to showing and teaching about environmentally efficient systems and technologies, and this can be used alongside abstraction to show how on a high level the player's actions can impact the world at large. In addition to that, we're going to be tapping into forced discomfort. With forced discomfort, we're trying to create a little bit of a sense of unease in the player. We are primarily employing this to try and make the present moment that we live in today seem more uncomfortable in contrast to the idealistic future which we're trying to represent. Finally, we're going to be leveraging conflicting goals. So this is about balancing choices and representing different alternative incentives in our world. And so we're going to have different points of view requiring the balancing of choices that the player makes throughout the experience. So now I'm going to go into a really early demo video of our game. So this is a very work in progress build, but as you can see, the player will be walking around sort of exploring our idealistic future, engaging in conversations with various NPCs as the dialogue propels the narrative which the game takes place in. A lot of these assets will be switched out with non-T-pose animated sort of assets. And then there's also a puzzle mechanic. So this involves the basically the distribution of garden beds and solar panels in order to try and provide an optimal amount of shade for the garden beds. And so in solving these puzzles, the player is going to have to balance the perspectives of various NPCs with regards to power output, garden efficiency, and also like the cost of these systems. In addition to that, there will be interstitial segments of our game in which the narrative is being propelled through images, which will be placed instead of that black screen. There's also a photo-taking mechanic. At various points in the game, you'll be able to take photos of various emerging environmental technologies, helping to educate the player in the domain of these systems.
As we said, narrative is a large part of our experience, so let me give you a brief overview. Our experience follows an environmentally focused community group known as Project Ecotopia and shows the effect that they've had on their community over time. In doing this, we have 5 primary characters that show up at least one of our time periods. To start, we have Miri, who serves as both the player character and the primary narrator. Next, we have Asha, who is both Miri's mom and also the founder of Project Ecotopia. And finally, within the family, we have Olive, who is Miri's child and represents the next generation of Project Ecotopia. Outside of the family, we have Mr. Gideon, who is the landlord and the owner of the building in which the story takes place, representing more of a capitalistic view of activism. And we have Eddie, who is an electrician and provides more of the technical knowledge involved with the work. In terms of our story structure, we show change over time by focusing on 3 distinct time periods. How Project Ecotopia began, Miri's proudest moment when it comes to hands-on work for Project Ecotopia, as well as the celebration sort of at the end of everything. Once we had these 3 time periods, our next step was to try and plan out how long we wanted the story to span. After much consideration, we settled on a time span of about 30 years, spanning into the recent past of 2015 and into both the near and distant future, all the way through 2045. Translating the structure into our game, we have 7 chapters, alternating between exposition portions and interaction. The exposition portions, as interstitials, as Farrah said, show the actual story through 2D images and dialogue. These are primarily told in the context of Miri giving an interview about the work that her and her family have done over time. The even portions are interactive, in which you can actually engage with the world playing as Miri and see the changes over time and actually be a part of making those changes happen. Our structure in this way allows us to focus on different IGDA tactics throughout. In 2015, we have forced discomfort by focusing on how intimidating and potentially nerve-wracking it can be to start a movement from nothing and the uncertainty of not knowing if it'll pay off. In 2030, we have conflicting goals as demonstrated by the various constraints within our puzzle mechanic, showing that you have to please multiple people at once. And in 2045, we lean heavily into systems knowledge by showcasing the different technology available in our world.
shader, which allows us to achieve that cel-shaded art style. And lastly, we also want to mimic the visual style of some familiar and classic pieces of media, which have some of the themes that we want to touch upon in our game. Talking about our visual targets, most of our visual targets were selected from classic movies by Studio Ghibli, because we felt that a lot of the themes which are reiterated in these movies are themes we want to touch upon. Essentially, the first and most important theme is the idea of opposing hyperproductivity and that of endless economic expansion. Secondly, the ideal of reaping the reward of your own hard work, that a community can benefit from their own actions and initiatives, is another theme we want to touch upon. And lastly, the idea of living in harmony with nature. So, let's talk about how these goals help drive decisions in our character art pipeline. So, as we can see from the concept art, we have characters like Asha and Miri, who will appear multiple times in the story in different time periods. And we need them to be, their appearances to be able to evolve to show the passage of time. So, this is where our art style really helped us support this from a tech art functionality, where we were able to approach the character art design with a very modular approach that allows us to reuse characters and textures to create the variation that we need. The modular approach means that we were able to take the same character asset and simply reskin it using textures and different meshes to provide a different appearance. Moving on to animation, we were able to use the same modular approach, where we want to rely on an emote-based animation system, such as this example from Fire Emblem Three Houses, which is this animation style is very reminiscent of visual novels. The advantage is that you will see characters react to the different dialogue choices you make in the story, but this approach also helps us limit the number of states in our animation state machine. So the pipeline we followed is to model all of our character assets in ZBrush and Maya, and finally build out a simple biped rig which allows us to both reuse the rigs as well as animations for all of our character assets.
Okay, so next we're going to talk about the environment in our game. So at the very start of the semester, we try to use different collage to test out different color palettes and test out different community themes. One is more about community kitchen and dining area. One is more about gardening and renewable energy. We also try to use this to have a better sense of the scale of the roof we're going to make and create a clear scope about how many assets we're going to make on our asset list. And we also use these rough 3D models to do our level block out before quarters, and we can do iteration further on.
So I'll talk a little bit about the layout of the three interactable chapters. The playable area in each chapter will be outlined in green. So in 2015, the first playable chapter will allow you to only move around the beginning of the rooftop where you would enter it. In 2030, in chapter 4, you'd move to the center of the rooftop where you'd see how technology has been added to the rooftop and how it has changed since this 2015 time period. In chapter 6, you'll be allowed admission onto the adjacent building's rooftop, as well as back into the previous chapter's location, so you can see how the space has evolved over the last 30 years.
Okay. As you can see, the current progress of all the environment assets, not texture yet. And our chapter 2 roof is more about focus on the narrative of relatively bleak and empty space for players to take initiatives. So we have very few assets in our scenes, and we'll try to adjust the material and skybox for the color tone. And for the near future scene, we try to utilize the sensory affect strategy by combining our community space with greenery and renewable energy. For instance, we have solar panels as canopies and use wind turbine to create different shapes and shadows, and use these farming units to create the interior space in between. And we also try to use this structure to define different openness in space and try to let them experience the spatial compress and release during the experience. And when going to system knowledge, we try to model different kinds of urban farming units that are already commercialized. So agrivoltaic system is the one you can interact with, and hydraulic vertical farming system and hydroponic system and so on. We will try to make it as authentic as possible so you can link this experience with real life information.
In 2045, in Chapter 6, you'd see a variety of the same visual practices that you'd see in 2030, as well as some new ones. This includes things like recycled decor, as well as different forms of frame space that also allow for new recreational and community gathering spaces. In addition to these new places to hang out, there are also some new exclusive tech to this time period. These include things like algae decor, an aeroponic system, a new verticrop system, a prototype hydroponic tree, as well as various wind turbines.
All right, and I'll talk briefly about the future of our project. We already have a few key milestones mapped out for the project, the first of which are playtesting our first fully playable build starting on week 8. We have 2 playtests scheduled that week. We hope to have our script finalized by week 10, and we hope to have a final build of this game by week 12 that gives us a buffer at the end of the semester to help prep for festival submission. One of our goals is to submit this to festivals like Games for Change, so we want to make sure we have time to prepare those materials. We want to give a special thanks to everyone who's helped us along the way in this project, and thank you very much. We're open for questions.
How was the future date chosen? Like,
So,
that many years in the future, how did you come up with that?
yeah, so the question being, how was the future date chosen? We knew that we wanted to show the change over time, but we wanted it to be something that not only showed that the project still has a future to go. Like, we're not trying to say that all the problems are solved and the work is done. Let's just look back and try and reassure you that everything is okay. We wanted to show that the work will still continue while also balancing reasonable change compared to what we are living in current day, especially knowing that we were rooting it in the 2015 past time point. So I believe we originally talked about the idea of it being more over the span of 70 years, having some of the characters sort of switch in and out, but between the character budget that we had and also the realism of the change that we wanted to display, 30 years was the best estimate that we came up with, in addition to talking to our various advisors about what sort of reasonable change we could expect.
I'm curious if you have any plans to reflect on the use of the IGDA playbook and possibly bring some of that reflection back to the community that has worked on it and continues to use it.
So the question being, are we looking to reflect on the use of the IGDA playbook and possibly give that information elsewhere?
Yeah, we absolutely have plans to share all the work we've done with the IGDA sort of community, and we are currently on their Discord server and communicating with people who are very involved in that process.
We also hope to have this added. They have a database of games and the tactics that are used within them. And we hope to have our game, we've been talking to them on the Discord like Farah said, we hope to have our game added to the database as well as a list of the tactics that were used within our experience.
The art and the story seem like they're very strong. So strong that I'm wondering if you turned off the interactives, what gets lost? Would you be willing to do an A/B test where you ran through it without the interactives and see what are the interactives bringing? Because that's really what I'm getting down to.
Well, our interactives are bringing a number of various things at different points in the game. One example is at the very start of our narrative, we have an emotional onboarding process where we try to meet the player where they're at. So we ask the player questions which are based around the profiles that we made around our target audience in order to try and guide them more towards the messaging of our game from the place that they start from. As a purely AV experience without interaction, we would lose the ability to meet the player where they're at in that regard, in that particular example. In addition to that, with the like puzzle mechanics, which occur around the center point of the game, the idea is to help the player feel a sense of contributing to improving this world, but also having to consider these various perspectives in their decision making, which allows them to integrate that tactic a lot more deeply and personally since they're making those decisions directly as opposed to viewing them from an external perspective.
Yeah, I think you have an opportunity to show game plus narrative can do even more to get to your 5 points. So I pursue that because these are so strong. I want to see these people grow up. I want to see the environment change, but I'm curious what the interactive can do for that.
Jesse.
This project seems very ambitious, and I'm concerned there's not a lot of room for to cut. How are you handling that?
So the question being about scope, what could we potentially cut? Along the way, we have been setting priorities for ourselves in terms of what are the absolutely most necessary elements. A lot of the things that have already been shown are the elements that we thought were most important to the story. We've also had that conversation with regards to characters and how easy would it be to rewrite the script if we had to cut the landlord or had to cut the electrician. So along the way, we've been making those sort of more meta analyses of our process so that if when push comes to shove, we know what would be the first to cut just based on the internal dialogue that we've had.
I would also like to add to that, that one method we've been taking to mitigate such a large scope is playtesting different components of our game in isolation. So for instance, we've been playtesting the narrative through a PowerPoint slideshow that we made early on. In addition to that, we've also been doing playtesting of the puzzle gameplay. So in total, that's 4 playtests with 21 people, and they've all kind of been in isolation to one another. So already we've had to cut various features along the way. For instance, our original puzzle design was this more isometric 3D perspective, but that was too visually confusing for players, having to think about how shade works across 3 different time periods. And so there was an evolutionary process there.
Okay, thanks.
Awesome. Cool. Thanks, Steve. Thank you.
And that is the end of our house presentations. Thank you so much, teams. Congratulations. And faculty, we're going to go talk about some feedback.